Welcome back, main hall. Our first talk of the afternoon session is Reaching New Heights in Python Education, Success of the 2023 Coding Summer School. Binjamin Barsch will be presenting for us. Binjamin is the lead software engineer at the Center for High Performance Computing, a research center that forms part of the CSIR. Binjamin has a very impressive bio on our website, but he's told me basically the first thing he's going to tell us is that. So we'll hand straight over to Binjamin. Binjamin, thank you.
Thank you very much. Thank you, everyone, and it's a pleasure to be here and present today. So as Kim said, I'll be focusing on, the topic today, which is reaching new heights in Python education, focusing on the coding summer school. Just a bit about myself. So I did my undergrad in mechatronic engineering at Stellenbosch University. Straight after, I worked for a company called FlightScope. They developed sport tracking technology, and I focused on digital signal processing, did Python, C, C++, and also did my master's part-time at UCT, focusing on radar and digital signal processing. And then 3 years ago, I moved to the CHPC. There I'm the lead software engineer. I do research, software and systems engineering work. I work a lot with Django, Flask, Postgres, full stack development. Yeah, so that's a bit about me, but more about the talk today is going to be focusing on the coding summer school. Now, before I discuss what the coding summer school is, I need to give a bit of background into what the CHPC, our mandate, to give you a bit more context into what the coding summer school is about. So this is just a brief overview of what we cover. CHPC, what is HPC? Then I'll discuss coding summer school and some other aspects related to the coding summer school. So firstly, I work for the CHPC, Center for High Performance Computing Center. It's a national facility funded by the government and administered by the CSIR. It started in 2007. It's based in Cape Town. We provide two main services, that is compute and cloud resources for academia and industry. So pretty much a competition to AWS as a Google Cloud. However, since we're funded by the government, we provide these services for free. Regarding compute, we have a petascale supercomputer. When it was launched, it was the fastest supercomputer in Africa, about 33,000 cores, and also have about 30 V100 GPUs. Regarding cloud, we have an OpenStack cloud service, 320 cores. There's some info there. We have dedicated domain areas as well: physics, chemistry, applied math, astronomy, science, computer science, engineering, various fields that we cover. Over the past 7 years, we've had over 1 billion core hours that have been used by researchers from all across the country, as well as SADC countries as well. So Python is the most used language by researchers and supporting staff. And I'll go into a bit more depth about that shortly. If you're interested in CHPC or using our resources, you can log onto our website. You can apply if you want to use resources. There's also commercial options as well. Now, before I discuss the coding summer school, I also need to discuss what is HPC, because most people aren't too familiar with HPC. If I mention cloud, everyone knows what cloud is, but what is HPC? So what is HPC? If you have a very complex problem or simulation you need to run, or you have a big data problem, you can't do it on your own laptop or PC. You need to move on to high-performance computing, which is just bunching a whole bunch of computers together. They work together to solve the problem in layman's term. They have shared memory, storage, and very fast network. So what are some applications of HPC? So we have a partner project with the SKA. The National Weather Center uses our data center at times to predict the weather and climate modeling. If you want to look at do CFD, airflow of a Formula 1 car, these are type of simulations you would need a HPC cluster for. And also quite well known if you want to develop a large language model, using a cluster is most ideal for that. So HPC and Python, there's obviously a lot of work that is done at our data center with machine learning, developing LLMs, image processing. using Python, with pipelines and workflows, pre-processing, post-processing, file transformation, parallel programming. However, there's obviously some performance limitations with Python, if you compare it to C++ and Fortran, but there are ways around that. You just see here a few, libraries that, are used with the HPC Center, and some of them might be familiar to you. So since these are some libraries, Python libraries that are used, one of our mandates is actually to help train our researchers, to actually use these libraries on our HPC, as well as we do training for cloud as well. So one of our mandates is for training and what we call human capital development, where we upskill and develop core skills for academic and research institutes across South Africa. We support infrastructure development and establish collaboration across institutes as well. We also develop training material in all South African languages, which is a new mandate that we started this year. So that's a bit of a training mandate to give you a bit of idea what the CHPC does. Now we're moving on to the coding summer school, the key topic for today. So this started about 13 years ago, pretty much when the CHPC started as well. And 13 years ago, it was like an annual physical event over 2 weeks, typical coding summer school environment where we teach postgraduates, in this case, programming and computational skills using Python and Bash. So this was pre-COVID. The coding summer school is also jointly organized by the NITheCS, or the National Institute for Theoretical Computational Science. So this was a joint effort that started about 6 years ago. However, during COVID, things changed. Obviously, everything went online, so the coding summer school also went online. But our reach for students increased to about 150 postgraduates, which was a huge number, and we're very proud of that. And after COVID, we decided, okay, let's maybe expand that. Let's see how can we expand this to maybe more institutes and more students that benefited from our summer school, the Python libraries and concepts that we're teaching them. So let's maybe expand it to other institutes. So we opened up registration to as many institutes as we could. NITheCS has a very large base for that. So they pretty much contacted all universities in South Africa. We opened up registration in October 2022, and the numbers were quite impressive. So we were actually able to get representation from each university in South Africa. That's about 27. We had 775 registered students that applied. Majority of postgraduates, honors, masters, PhD, and postdoc. We also had 2 research institutes, namely the South African Medical Research Center, as well as the Timber Labs, also joined the coding summer school, where they wanted to get students, trained up in the Python content that we were offering. The top domain areas were physics, chemistry, and computer science, but it was quite a broad spectrum of different domains as well. So this is just to give you an idea of all the representation that we got across the country. Now, a lot of because this was quite a large project, we needed to, get a lot of information about who are we actually going to train. What's their background, where they're coming from, and whatnot. So first off, we needed to get an idea about the institutes, how many students are going to be at a physical institute. So let me just go back one slide and just give you context. The model that we decided on was we will have a physical venue at each of these institutes. We will stream the content live from one institute, namely this is at UCT, and we'll pretty much have the coding summer school live across the country, while everybody's learning and engaging. So you can think there's quite a logistical issues that were involved, and at each of these institutes, we needed a champion or a representative that needed to make sure the logistics were, supported in terms of the venue. There was power, internet, everything, right? So just imagine all the institutes working and collaborating together is quite a phenomenal thing. So again, this was the breakdown of the number of students from each institute. You can see I think the top 15 universities had, like, on average, more than 20 students that registered that were going to plan to be at the physical venue at these institutes. A few other institutes had less numbers. There were 3 universities that did have students but didn't, have a venue and time. So I think Walter Sisulu and Mpumalanga, Soplaki weren't able to have a venue. So in total, we had about 27 institutes that were, ready to go. Just a bit of other, stats as well, just to give you a perspective. So physics was a domain background that most of the researchers or postgraduates came from, but also had chemistry, computer science, and various other fields that came. But we had quite a dynamic group this year. We even had people from accounting and the medical field as well join. So again, just to understand more about the students and what they're looking for, most of them were looking to just learn more about Python to help them with their research. And also, again, to understand who we're teaching, we need to know their background in programming. What do they actually know about programming? So quite a vast number of them knew Python. What we were focusing on was this section, the number over here, 181, that use spreadsheets for their research. So that was our target group. How we're going to train these researchers that use spreadsheets for their research. And again, just get an idea of familiarity with software, just to understand what teaching stack and IDEs we can use. So most we're familiar with VS Code and Spider and Anaconda, but again, 201 weren't, right? So we had to also take into consideration how we're going to first get familiar with Python IDE. And again, getting a bit more details into the libraries that students knew about. Again, as a broad spectrum of libraries that they knew, but again, most important one we focused on is teaching those that have least knowledge of it, and there's quite a lot of students in that category. And again, just focusing on what type of data files that they were using. So this leads on to how we're going to train the students, what data they're going to use, and how to cater the content in that way. So most were using Excel and CSV files and text files. An important mandate that started at the beginning of this year was to translate our content into the official language of South Africa beyond English. So one of the stats we got was, based on the students, what was their first language? And this was stats that gave us, isiZulu, Sepedi, siXhosa, and Sesotho were the top 4. And our mandate is actually to translate Python content into these languages. One last stat that we got, just to get an idea of who we're teaching, is the superheroes, right? Just a bit of a lighter side, and the famous ones were like were voted in the top few. I got some strange ones as well. Some people said me, some said the grandmother, some said the mother. So some people had a variety of superheroes in their life, which was interesting. So now we had an idea of the students we're going to teach. This was the first time we were teaching so many students, and the logistics, as you can think, is scaled to another degree. So we had to expand our team, and again, as I said, the Coding Summer School was collaboration between CHPC and NITheCS. From the CHPC, we had 9 staff members that focus on logistics, infrastructure, and teaching, and you have a few examples there of the different roles that each member played. But again, to this scale, we need a larger team. And from the CHPC side, we had 9 people. From the NITheCS side, they also focus on logistics, coordination, and teaching. They really pioneered the coordination with all the universities. So they had the context, and they were able to organize the logistics. Again, there were 7 people there. And as I mentioned earlier, we also had the champions at each institute that needed to manage, like, the venue, there's power, and everything else, the snacks as well for the students. So, but I just want to give you some idea of, like, the logistics behind it was quite a challenge. Now, just to give an overview of what the coding summer school, looked like, happened for 2 weeks from in the early January, so 30th of January 2023, earlier this year, from 9 to 4. Each day we would have lectures and tutorials, interactive quizzes. First 3 days was Introduction to Python. Then we had some content on Bash. And then we also had daily STEM talks from people, leading STEM researchers, or from industry and from academia, just to give our students a bit of idea, like where do they use Python in day to day. So that was for week 1. Week 2 was a bit more advanced content that we taught. So focusing on linear algebra, probability and stats, ODE, machine learning. And just to give you an idea, of the 775 students that actually registered, we actually only had 535 active students that actually participated in the day-to-day activities and did assignments and quizzes. So of those, only 350 qualified for certificates in terms of completing all quizzes and assignments and whatnot. So that's generally what the Coding Summer School comprised of. In terms of the teaching stack, we chose Anaconda. First week, we focused on Spider. Spider we decided on because uniquely it has a similar to structure to MATLAB and R as well. Also, students that are familiar with Excel, as you know, there's a variable explorer in Spider, if you don't know Spider, but it's easier to kind of see the data that you're working with and manipulate or write code with it. So Spider gives you a nice environment for people that are new to coding. Jupyter was only used in the second week. Jupyter kind of gives students a bit of difficult understanding if they don't know coding initially. In terms of our LMS, where all our content was located, we use Canvas. We did use Moodle before for many years, but there was some issues we had with updating Moodle. So we used Canvas online, and it was a fantastic environment to use. We also used Zoom to stream all the content live for the 2 weeks. And importantly, we used Slack, which was our main communication medium. This really allowed us to communicate with students all across the country at the same time while the lecture is happening. So each venue had its own channel. And we also had a general chat where, as we were teaching, we could ask questions in the Slack chat and get instant feedback, which really helped. And we asked students not to ask questions in Zoom, so we can obviously record all the questions and comments that we have in Slack. So Slack was our main medium for communication and worked quite well. This is just a quick look at what Canvas looks like. If you're familiar to Moodle or any LMS, we grouped the different sections in week 1, week 2, and the contents. But this is, the look and feel is quite similar to any other LMS. One thing that's nice about Canvas is the API interface. It's quite broad, and you have pretty much all access to any aspect of Canvas, which is very nice. So again, one of the success stories, I guess, of the Coding Summer School was we were able to translate our training notes into NITheCS. So what we did was we took English notes, and we got an external company to translate it. And then our staff that natively speaks NITheCS, they reviewed it and looked at different ways to kind of modify it, because the external translator used very classical language. So some words had to be changed and modified. So our local staff were able to modify it to suit our needs and make it more modern. So one of the mandates is obviously to provide training material for people who don't speak English as a first language, because there's definitely a bias for English speakers having all this content available. What's quite interesting as well during this journey that while we're translating this to NITheCS is we're looking at redefining how words are used. Is actually how languages are kept alive. So this also leads on to another important concept of LLMs for African languages, which are limited in resources. We obviously know about ChatGPT, but it has a huge database that it was trained on. African languages have a very small database, so this is something for African languages. There's a group called Masekane that is leading this. Developing LLMs for African languages. And one interesting thing was, there's a common approach to anglicize words. It's in Afrikaans and Xhosa as well. Just adding a e to the, like you say, e programmer stops languages like Xhosa from actually growing, right? So keeping languages alive are quite important to redefine how words are actually used. So one example that was pioneered by our staff was a word for programmer, right? So Xhosa it's umbala ikrobu, right? So umbala means a writer, ikrobu means a procedure. These two words together came up with the word for programmer, right? So these are words or concepts that have actually been developed before. But it's an interesting concept. This is how languages are kept alive and how they grow and made modern day. So one example I always think of is when I did my undergrad at Stellenbosch University. I learned in Afrikaans, and they did. My first year was in Rekenaarwetenskap, right? So I always where does the word rekena come from? Right, it's the same principle, when words are redefined to be used in a modern day language. And there's just an example below as well of how, now this is just one of the notes on Bash. You see the English on the top here, and below is Xhosa. So again, this is a pioneering effort of our local staff at CHPC to develop this content. And we plan for next year to expand that into Setswana, Sepedi, and isiZulu. All right, so just a bit of background into a day-to-day timetable that we had. Again, 9 to 4. We had first 3 days just basic understanding of Python, looking at data science, data visualization, and then Bash as well. And again, with Hobos 1, we had STEM talks from various researchers as well. So just to give you context, how did this look? So there's me over here at UCT, streaming live to all the universities at the same time. And there's a few other universities, the centers that they had that are also there at the same time, just giving you an idea of how it looked like, how it happened. And it actually worked very well, surprisingly, thinking of all the logistics that went involved. But again, it was a huge team effort to get it to work. So certain achievements I think that we kind of took from this was, again, we had quite a large registration. Just under 658 were on Slack actively. Again, Slack, we had 29 venue channels, so each venue had its own channel. The champions and the students could interact, like, where's the next venue, or where's the venue, or any other logistics. We had a help channel, champions channel, and a general channel. So Slack was really great as a communication medium. Again, we had 556 active students on Canvas. On average, we had about 200 students in total at the venues, and 250 attendees per day as well. 350 qualified for certification. And then we also had like prizes of book vouchers for students that did the best in assignments and the quizzes, and those that are most active on Slack as well, ask lots of questions and all kinds of things. So we had prizes at the end, which everybody appreciated. Now, just a bit of feedback. Once it was all over, what were the pros and cons that we got? So most students found it was a good introduction to coding for various disciplines, and some participants found the pace quite fast. Not surprisingly, it was those that were new to Python, but overall the instructors were knowledgeable and provided step-by-step approach to learning, and it was a good refresher for those that knew it. One issue, well, two issues we had was the lack of tutors, so we weren't able to get tutors in time to actually be at the venue, so that was one downside of the coding summer school, and the logistics we didn't have time to organize. Just have tutors at each, or enough tutors at each venue, so they could help students that were struggling, and just to help the champions as well. Also, week 2, unfortunately, focused too much on physics domains, so computational and numerical methods were the main focus. Unfortunately, this was irrelevant to people in medical, life sciences, and accounting, right? So this is something we had to change and focus for next year. And again, just to get feedback, so about just under 7.5% used the notes, CSIR notes. Interestingly, the reason most gave were they're not proficient at reading, understanding CSIR at this level, and also that, but generally it was they were happy with it, and it was easy to understand the whole idea, and they were happy with the initiative. And we also got a survey getting information. Most wanted, the content translated into other visual languages as well. Also, just a feedback on the hybrid model that we used. So in-person pros, it was easy to focus on in class, easy to ask questions and collaborate with others, more engaging. The cons, commuting early in the morning was one con. Online pros, because some students were only online. It was always convenient, but online con was obviously that there was load shedding. Yeah, so we're also now in preparation for the Coding Summer School 2024. So we opened our registration in July 2023 just to allow students, well, actually to allow the champions to organize the logistics earlier. So one issue we had was, not enough time last year for the champions to get a venue, get the number of students they knew about to organize it. We actually have a champion at the back, Kim Martin, behind the desk over there. So she was a Stellenbosch University champion. She's over there. So I think Stellenbosch had the most students as well. So you can ask him about that. And yeah, so currently we have about 600 already registered. Our target is about 1,000 for next year. And again, our focus is also to translate to isiZulu, isiXhosa, Sepedi, and Setswana. Why those 4 languages only is we need local staff that can also support the languages. And those are the only 4 languages we can support at this time. Yeah, and a bit of background into week 1, which is similar to what we did this year. Pandas from day 1, just based on the feedback and the data that we got from students. A lot of the students who asked, just send me the data that you're working with, send me a CSV file, the Excel file, and most students just wanted to filter it and read it in and modify it. And we kind of realized that teaching the fundamentals of programming needs to be obviously catered to the students that you're teaching. So a question we were asking ourselves: should we teach them principles of a for loop? Because in Pandas, you don't really need that. So other aspects, obviously week 1, data visualization, analysis, data management as well. Week 2, our focus has changed a little bit more to cater for everyone in terms of generic topics. So first 3 days will be machine learning, probability theory, and stats. And we also have, in the end of the week, parallel topics on in various domains. So we'll be teaching NumPy, bioinformatics, material science, astronomy, and then other topics as well. Yeah, so that's all I wanted to kind of discuss, give you a bit of an idea of Coding Summer School, what we're doing at the CHPC, and on the initiative to kind of broaden the understanding of Python and how to use it for researchers across South Africa. Yeah, so just maybe, I guess this is the question time, but I actually have a few questions, 2 questions for you. Should Python be a common skill that is taught across disciplines, just like Excel? Because it's Excel, everybody knows it. And question 2, should Python be taught in South African languages like isiXhosa and isiZulu? So I have 2 questions for you to kind of maybe give feedback, and any other questions about what you do at the CHPC or the Coding Summer School, more than welcome to ask. Thank you.
Thank you, Binjamin. That is inspiring stuff. I can imagine the results in the next couple of years as more and more students and researchers and people actually doing critical work for South Africa know some Python, or at least some coding through some Python. So that's brilliant. Thank you. On behalf of, South Africa, I'll take it on my shoulders to say, brilliant. Thank you. Do we have any questions? Anyone in the audience? David's got one there.
Really, really enjoyed it. Also, the power of context. When you said school, I thought 7 to 17-year-olds. I wasn't thinking adults, because that's my context. Volunteer at helping young kids into coding. So question 1, most of them know Python and don't know Excel, so I completely agree. I just wanted to give you answer to your question. And for number 2, I really, really believe it should be, because it lowers the floor. And my talk last year was actually on how you translated turtle, so you can import fudo or fudu, and say fudu pambili kuhlu if you wanted to go forwards, rather than having to speak English to be smart. Because that's the big problem that happens.
100%.
A 6-year-old child who wants to do the thing but has to learn in English. It doesn't make sense.
100%.
Also appropriate for university students, but especially at the younger ages. So great. And I really loved the stimulating questions. A great presentation.
Thank you, David. There was a question. For a hand.
Hi. My question's actually around question 2. One would assume that a majority of the students at CHPC or doing this summer school are people who are already postgraduates.
Correct.
So they already had to climb the language mountain, so to speak. But as a person that dealt a lot with first years, especially at first year chemistry level, that's where I've seen the biggest problems with language. Is there, I know it's within your mandate, especially CSIR, it's a higher education thing, but is there a possibility, because I think it starts becoming relevant if you're saying, no, we bring this to the high schools, because that's where the problem really is. A person who's already finished with that, so yeah. I don't know.
What's an interesting point, when I was after I finished studying Stellenbosch University, I went to FlightScope, and FlightScope was in Technopark, which was like the Silicon Valley almost of South Africa at that time. And the people that ran FlightScope were Afrikaners. Our meetings were in Afrikaans. It was a high-tech company that they still are around, and they have headquarters in Florida. But the meetings were, the notes, everything was still in Afrikaans. So I don't think once you finish your postgraduate, you've reached a ladder. You're always learning, you're always developing, and to be able to speak in your own language allows you to think differently and speak to other people differently. So I think high school, obviously, for first year, and we had primary school as well is even more important. But I don't think there's any limit to when you stop learning.
Thank you. Question. One online question from Ndiyabonga Sakomba. It's asking, did the training encompass fundamental computer basics before getting into Python? For example, in other words, core computing components, network fundamentals, software fundamentals, noting that perhaps they feel that may have laid a good basis.
Sure. So part of our registration is to get an understanding of what the students know and are they familiar with, computers and whatnot. So we had that as a, criteria already to know if they are able to, be part of the course. Just to give a bit of context, the CHPC does various training, and one of them is for DSI training, which is actually training teachers from various schools from across South Africa, the principles of how does a computer work, from scratch, like building a computer, taking it apart and putting it together, principles, the very basics of Python and Bash as well. So they can go back to their learners and teach them as well. So we have a different, training for that focuses on, basics of computers and how they work.
Thank you. I'm pretty sure that was a fairly comprehensive answer to the question. Thank you. Any further questions? Anyone from the floor? Gina? So was it one here as well? Or? Okay. Gina. Yeah, we can get into questions.
Yeah, great talk.
Thank you.
I'm also in education, so very keen to chat later as well.
Sure.
My biggest question probably is, how do you train the trainers? How do you train the tutors to do a good job?
That's an excellent question. So, firstly, we obviously have to know what capabilities they have. So, do they know Python and they're able to tutor? We can't know everything related to what the tutor will know, obviously, and also it's also up to the champion to filter that. The CHPC and NITheCS has their roles. The champions at the institutes need to do theirs as well. So you can speak to Kim as well about the sometimes a nightmare of logistics where we had to do. But yeah, it's a good question. How do you make sure tutors are capable, and more importantly, how do you encourage tutors to actually come and tutor, because they want something. They're not gonna, the postgraduates, and you need to entice them to come help students as well. So it's a good question.
It's really tricky, because just knowing how to code doesn't mean you know how to explain it.
100%.
Yeah.
And then one more question from.
Thank you. So when you did the move from in-person to remote learning, firstly, were there, and secondly, what were the changes you had to do to the teaching style and how you presented and taught the content?
I think the content was again catered to the students that registered. So our forms are quite rigorous. Students have to take time to actually fill it in, so we know exactly who we're teaching, so we can cater the content for that. So pre-COVID, it was more focused on specific domain areas that we could focus on. So there was a huge, focus on like using NumPy, SciPy, and various other computational aspects that they need to learn. Once we moved to online and had a broader reach over various other domains, we had to kind of start teaching more generic principles of Python. So focusing on NumPy just wasn't enough. We need to just start with pandas, and then maybe focus more on general data science aspects and teach those principles. Even data management, how do you store data correctly, storing variables correctly, all these things. Students don't really know these basic principles. So it's having a broader reach kind of gave us perspective of what postgraduates actually need to actually know how to do their research, because they aren't taught these things.
Awesome, thank you. I'm going to wrap things up in the interest of multiple languages, which is always admirable, with thank you, dankie, merci, sheshe, and gebonga. Thank you. I think that's it. Binjamin, thank you. That was absolutely brilliant. Yeah.